In this video and in the next several videos, we are going to talk about the idea of continuity and also one-sided limits. We'll first, in this video, we're going to look specifically at what is continuity, and then in future videos and later videos, we'll talk about the one-sided limits and ideas of discontinuity. Right. But let's first think about, come up with an intuitive definition or idea of what it means to be continuous, right? So a function is continuous, right? Is continuous if its graph can be drawn without lifting up your pencil. Right? And so what I mean by that is you can draw that graph, and there's no holes, there's no gaps, there's no jumps, there's no vertical asymptotes, nothing like that in the graph. So I could draw a graph here where maybe you have something that looks like this. But out here at 8, maybe there's just a hole in the graph. If that was the case, we would say this graph is continuous for all values of x that are not equal to 8. And it is discontinuous for x equals 8. Right? So it's continuous when you can draw that graph without lifting up your writing utensils. Without lifting up your writing utensil. You can have then, for continuity at a point, a function that is continuous at C if there is no hole, gap, jump, or vertical asymptote when x is equal to C. Right? And so if you had something like this, this is not continuous at C. So even though it's defined at C, right, there is a function value at C, there is a jump right there. You can't draw this picture without lifting up your writing utensil. Or if you had something like this, where you have this vertical asymptote. If that vertical asymptote is occurring at C, it is not continuous at C. Right, and we would say it's not continuous. Perfect. So that is the idea of continuity. It's continuous at a point if there is no hole, gap, or vertical asymptote when it's equal to C. Right, so we can talk about continuity over a range of values or at a specific point. So how do we define continuous? Right? And so we will say a function is continuous at C when these three conditions are met. So the first condition that must be met in order to be continuous is the function has to be defined at C. Right? So if there's if the value C is not in the domain of the function, if there's no function value at C, then it can't possibly be continuous there. Second thing we have to have true is the limit has to exist. There has to be a limit as x approaches C. Right? So as you approach C from either side, it needs to be settling in on some value. The function needs to be settling down. It can't just blow up to infinity. It can't go to two different values. Right? And then the third thing that must be true is that function value at C and that limit as x approaches C, those two things have to be equal. Right? So our limit as x approaches C needs to be equal to the function value at C. When we have an open interval, we can talk about continuity on that open interval. Right? So a function is continuous on an open interval from A to B when the function is continuous at each point in the interval, right? So not necessarily at the endpoints, but every point in that interval. A function that is continuous on the entire real number line from negative infinity to positive infinity. It is continuous everywhere, or everywhere continuous. Right? So when we think about that continuity on an interval, intuitively, if we're going from A to B, it means from A to B, I can draw my picture without lifting up my writing utensil. Right? And it could have open values there. You could have a defined value here because we're only thinking about the open interval from A to B, and we can talk about continuity on those open intervals. So that's our formal definition of continuous. It needs to meet these three conditions in order to be continuous at that point. So the function value needs to exist at that point, the limit needs to exist at that point, and those two values need to be equal. That's an idea that you should probably have down. You should take time to learn and know that relatively quickly. All right, in the next video we will talk about discontinuities. I will see you there.